Very good morning to all of you. Today I want to start Pile Foundations of Module 5 Session 3. Course outcome capable of estimating load carrying capacity of single and group of piles. Subject title is Applied Geotechnical Engineering and that subject code is 18 CV 62 of 6 semesters and it comes in civil engineering branch. Contents. Today I want to explain in details about group capacity of piles and efficiency of pile group. So this is the headings and subheadings are number of piles and pile spacing, group capacity of piles, efficiency of pile group, by converse Labre formula, by field rules. So these are the contents required to cover in session 3. Let us see in details about group capacity of piles. A structure is never founded on a single pile. Piles are usually placed sufficiently close below these structures. Hence, the action of the entire pile group must be considered. This is particularly important when the piles used are purely friction piles. The bearing capacity of a pile group is not necessarily the capacity of the individual pile multiplied by the number of piles in the group. The phenomenon by virtue of which this discrepancy occurs is known as group action of piles. Okay. Now I want to explain number of piles and pile spacings. How number of piles are decided and how pile spacing are decided practically. Okay. Usually driven piles are not used single below a column or a wall because of the tendency of the occurrence of eccentricity during driving. Hence, piles for walls are commonly installed in a staggered arrangement to both sides of the center line of the wall. For a column, at least 3 piles are used in a triangular pattern. When more than 3 piles are required, the arrangement of piles is symmetrical about the point or area of loading applications. Column and wall loads are usually transferred to the pile group through a pile cap, which is typically a reinforced concrete slab structurally connected to the pile heads to help the group act as a unit. Now I want to explain about spacing of piles. The spacing of piles in a group depends upon a number of factors such as the overlapping of stresses of adjacent piles, that is stress zones, cost of foundation, and the desired efficiency of the group of piles. An optimum pile spacing should be used to strike a balance between the conflicting criteria. Point bearing piles may be more closely spaced than friction piles. The spacing may vary from 2D to D, D being the diameter of the pile. The recommended minimum spacing may be 3D for friction piles. Group capacity of piles. How group capacity of piles are considered. Okay. So this diagram is explains. So these are the piles 1, 2, 3, and this is pile cap, and this is column loads. This is ground levels. Okay. Pile is inserted in the center of the pile cap, and these are the soil embedded between the piles action along with the group as a unit, and these are the skin friction on perimeter of the group, and these are the piles, and this is end bearing on plan area, that is base area of the group. So this figure explain the capacity of a pile group is not necessarily the capacity of the individual pile multiplied by the number of piles in the group. Disturbance of the soil during installation of the piles and overlapping of stresses between adjacent piles may cause the group capacity to be less than the sum of the capacity of individual piles. The capacity of the equivalent large piles is analyzed by determining the skin friction resistance around the embedded perimeter of the group and the end bearing resistance by assuming a tip area formed by this block as shown by figure 5.1 above. The end bearing resistance is computed by using Terzaghi's bearing capacity factors. Okay, so here number of piles if you are using, so you can calculate the block concepts and to calculate Terzaghi's bearing capacity factors. Negative skin frictions may be computed for a group in cohesive soils as follows. Individual pile actions is given by the relation Qng equal to n times Qnf equal to n into P into dc into C, and for block action equation is given Qng equal to C into dc into Pg plus gamma into dc into Ag. Here Pg and Ag are respectively the perimeter and the area of the pile block at the base. The larger of these two values for Qng is chosen as the negative skin friction of the group. P is the perimeter of the pile section. dc is the depth of compressible layer settling in relation to the pile, and C is the unit cohesion of soil layer which is settling. So these are the parameters are used to calculate negative skin frictions by using individual pile action as well as block actions by using above two equations, that is 5.24 and 5.25 for cohesive soils if we are providing pile groups. How to calculate efficiency of pile groups and meaning of efficiency of pile group. The efficiency neta g of a pile group is defined as the ratio of the group capacity to the sum of the capacity of the number n of the piles in the group. Based on the definition, the equation is given by Ng equal to Qg by n into Qp into summation of Qp, where Qp is the capacity of an individual pile. Ng obviously depends upon the type of soil through which the piles are placed and on which they rest, the method of installation and the spacing of piles. Group efficiency depends upon the type of soil, how they are placing and how they are rest, and method of installation and spacing of piles. Group capacity, efficient pile group is calculated. Vesic has shown that the end bearing resistance is virtually unaffected by group action. However, skin friction resistance decreases for certain pile spacings. However, skin friction resistance decreases for certain pile spacings. Thus, in general, efficiency of pile groups in clay tends to be less than unity. However, Vesic experiments indicate a group efficiency greater than unity in sandy soils. A number of empirical formulae have been proposed for the pile group efficiency. These invariably give efficiency values less than unity and therefore will not be applicable to closely spaced friction piles in cohesionless soils and to piles through soft strata resting on a firm stratum. Here, by converse Labre formula, how to calculate group efficiency is given by the relation Ng equal to 1 minus 5 by 90 times m into n minus 1 plus n into m minus 1 divided by mn, where phi equal to tan inverse of d by s in degree, d and s being the diameter and spacing of the piles respectively. M and N are the number of rows of piles and the number of piles in a row. By field rule, how efficiency of pile group is calculated. Here, according to field rule, the value of each pile is reduced by 1/16 owing to the effect of the nearest pile in each diagonal or straight row of which the particular pile is a member. This is illustrated in figure 5.2 below. See, so this is two piles single row, that is two pile at 15 by 16, 1/16 93.75%. This is triangular system, efficiency is 87.5%. This is square sections, 4 piles, that is 81.25%. Here 6 piles, 5 piles, 4 piles at 13 by 16 and 1 pile at 12 by 16. So here efficiency 80%. This is 9 piles, 3 into 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 3 by 3, that is 9 piles. 4 piles at 13 by 16 and 4 piles at 11 by 16 and 1 pile at 8 by 16. So efficiency of pile group is 72.22%. So this is the field rule to calculate a pile group efficiency. So based on the above slides, to calculate pile group efficiency, there are some MCQ short dates. Okay, here number of questions are prepared in terms of MCQ. So first question is the group efficiency of a pile group. Option will always be less than 100%. Second option will always be greater than 100%. Third option may be less than 100% or more than 100% depending upon the type of cells. Fourth option none. Option C is correct. Second question, based on the mode of supporting vertical pile loads, pile may be classified as dash piles and dash piles, that is friction piles and bearing piles. Second question, the minimum number of piles in a pile group should be dash. Option is 3. Next question, a long and relatively slender member placed into a solid soil is called a dash. Answer is pile. Number of piles required to support a column. Option is what? 2, 3 or 4. Option is 3. The maximum load carried by a pile when it continues to sink without further increase of load is known as ultimate load carrying capacity or ultimate bearing capacity or ultimate bearing resistance or all the above. Option is all the above. Generally the bearing capacity of a pile group is option equal to the sum of bearing capacity of individual piles in case of a friction piles. Second option equal to the sum of bearing capacity of individual piles in case of end bearing piles. Third option less than the sum of bearing capacities of individual piles in case of an end bearing piles. Fourth option is none. Option is B, that is equal to the sum of bearing capacity of individual piles in case of end bearing piles. Next question, the head of the treated timber piles after having been driven. Option is can support the pile cap directly, must be covered with a wooden plank to receive the pile cap, must be provided with a zinc or lead coat, then a hot patch, none. Option C, must be provided with a zinc or lead coat, then a hot patch. The ultimate bearing capacity of a group of bearing pile is Q is equal to N into Qn. Second option is Q equal to N into Qu. Third option is Q equal to W plus gamma LA plus SP into D plus L, or next option is Q is W plus gamma LA plus S into P into L plus D. Option is A, that is first option, Q UG equal to N into Qn. The ultimate bearing capacity of a bearing pile with its tip in granular soil is given by first option is Q equal to S times Q plus H into K tan phi. Second option Q equal to SCA into. Third option Q equal to A times 1 plus 3 times CNC plus gamma D NQ plus 0.6 gamma AN gamma. Fourth option Q equal to A times gamma D NQ plus 0.6 times gamma A N gamma plus S gamma into D minus 0.5 times HG into tan phi. Option D, that is fourth equations. So these are the references are made for session 3. Thank you and I will be continue next